Welcome to Question Bank. In this revision video, I have prepared in precise manner the rest two candidates of the thyristor series. Those are TRIAC and another one is GTO. And in this first session, I want to discuss about TRIAC. And first is, what is TRIAC? TRIAC is the term has been derived from triode plus AC. TRI from the triode word and AC as it is operated for AC. And this is a bidirectional thyristor with 3 terminals. As this is bidirectional, we cannot name it as anode or cathode. So we have named it as MT2 and MT1, that is terminal 1 and terminal 2. So next thing is, it has generally lower rating than thyristor in terms of all the parameters, that is voltage, current and frequency. It should be remembered. Another thing is, it is the structure, it is the physical structure, and it is well differentiated from the thyristor. First one is VI characteristic. VI characteristic of the TRIAC is identical only for the first quadrant, and the third quadrant is the mirror image of the first quadrant. Third quadrant is mirror image of first quadrant because it is operated in only first and third quadrant in both the directions. Because if we provide appropriate signal to MT1 then MT2 and gate, then it operates as it is mentioned. I will discuss it later. It blocks both half cycles of AC with no gate signal. That means if we provide no gate signal, it will block AC in both the half cycles, of AC. That means for positive half cycle and negative half cycle, it will block both the half cycles if the applied voltage is not greater than VBO. VBO is breakdown voltage, after which the junctions will be breakdown and current will start to flow. What are the uses of TRIAC? Generally, we have to remember that residential lamp dimmers, heat control and speed control of small single phase series or induction motors. And what are the operating conditions? These are the operating conditions which are main important thing for TRIAC. First one is, if we consider MT1 as reference, because here two terminals MT1 and MT2, if we consider MT1 as reference, then with respect to MT1, if we provide MT2 positive voltage and gate also will be provided with positive voltage, then what will happen? The current conduction will be from, this is the current conduction for first one, that is from P1 to N1 to P2 to N2. This is the current conduction path, and this is the current conduction path for the first and second condition. This is the correct conduction path. But in case of second condition, where gate is provided with negative signal and both M1 and M2 are as same as previous, then what will happen? Here this condition is same and this condition is same, but what happens? Gate is provided with negative signal with respect to MT1. Then what will happen? First conduction will be P1 N1 P2 N3. That is here P1 N1 P2 N3. This is the first initial condition, and then it will be converted to this one. That means P1 N1 P2 N2. So in this condition, when M2 is provided positive potential with respect to M1, always the final conduction path is P1 N1 P2 and N2. This is the final conduction path. This may be asked in the exam, what is the conduction path, and this is the final conduction path. And the operation, this is in first quadrant operation, because here MT2 is given positive. Here this is the first quadrant operation, MT2 positive with respect to MT1. So this is first quadrant operation. And the difference between both these conditions are, the second one is low sensitive because we need more gate signal to finalize the current conduction, that to P1 N1 P2 N2 conduction. So in general this is not preferred for the operation, preferred only the first one which is high sensitive. So in exam it can be asked which condition is preferable in first quadrant. So M2 is positive with respect to M1 with positive gate signal with respect to MT1. So this is the first condition, and the next two are M2 is provided with negative signal with respect to MT1 with both positive and negative gate signal. First one is positive and second one is negative. These are the third quadrant operation. And what is the direction here? Here also the same. Here is also the direction is constant, that is P2 N1 P1 N4, P2 N1 P1 N4. But in case of the third one, the sensitivity is low because first conduction will be in this way and then in this way. So this is less sensitive, and the third one is the fourth one is highly sensitive, that is the path is P2 N1 P1 N4. And here we have to remember only two things. In case of first quadrant operation, M2 is provided with positive signal with respect to M1 with gate signal is positive, and in case of third quadrant operation we have to provide negative signal to MT2 with respect to MT1 with negative gate signal. That means if for a AC signal this is positive half cycle and this is negative half cycle, for positive half cycle we have to provide positive gate signal because MT1 and MT2 terminals are permanent. Then we have to provide positive gate signal to flow current in the first half cycle and positive half cycle, and in case of negative half cycle we have to provide negative gate signal for high sensitive operation. So this is the end of this TRIAC topic. So I think this may be helpful for you, and next I am going to discuss about the GTO.